students, we are here today. In our video today, I am going to let us know that every quadratic equation is factorizable, provided the equation has roots, whether it is an integer root or roots of decimal numbers. So long as it has roots, it is factorizable. Unlike what we know before, that is some quadratic equations that are factorizable, while some are not factorizable, thereby making us to use the formula to get the roots or use completing the square to get the roots. But I tell you, even those ones that are not factorizable in quotes can be factorized, except it is a complex root. So let us look at this question. You know how we are able to identify if a quadratic equation is factorizable? Is by using this expression to confirm. And if you use this expression and you get a whole number or an integer, it is factorizable. So let's check whether this is factorizable as we know before. If you look at this, our b is 7. So you have 7 squared minus 4 times a is 1 and c is 5. That is going to give us 49 minus 20. And 49 minus 20 is root 29. 29 is not a perfect square, so root 29 is definitely going to give us a decimal number. By implication, we can say that this is not factorizable. Okay, but let me show you how you can factorize it. If you want to actually understand the theory of factorization, you will see that every quadratic equation that has roots is factorizable, whether in an integer root or a decimal number root. Okay, what we'll do is, remember what we usually do is to multiply the coefficients of x squared and the constant. So that we'll have 5 here. And we look for two numbers whose product is 5 and whose sum is 7. That is what we usually do. But we can see from what we know it is not possible. But why not we say this? Now, if two numbers, the sum of two numbers will give us 7. If I divide this 7 into 2, I am going to get 3.5. Okay, so if I have 3.5 in two places and I add it, I will get 7. Okay, but if I subtract a certain number from 3.5, remember 3.5 plus 3.5 is 7. So if I subtract a certain number from 3.5, I add that same number to this 3.5. If I add, I'll still get 7 because it's the same number I removed from here that I added here. So if I add them together, I'll still get 7. So that means that these two numbers are the two numbers that I'm going to add to get 7. And they are still the two numbers that I'm going to multiply to get 5. Of course, you see 3.5 plus 3.5 is 7 minus a plus a will give us 0. So if you add these two things, you get 7. And if you multiply, we should get 5 as we solve factorization. So let us now use this to know what this a actually is. If you look at this, this is difference of two squares. And of course, we can say 3.5 squared minus a squared is equal to 5. Okay, so 3.5 squared will give us 12.25 minus a squared equals 5. We'll move a squared to this side to make it positive. So we'll have 12.25 minus 5 equals a squared. 12.25 minus 5 will give us 7.25 is equal to a squared. That means that a is equal to the square root of 7.25 and a is equal to 2.693. So if a is equal to 2.693, and we say that the two factors are this and this. So the first factor, which is 3.5 minus 2.693, will be equal to 0.807. While the second one, which is 3.5 plus 2.693, will give us 6.193. So the two factors are 0.807 and 6.193. the implication is that this equation can be rewritten as x squared plus 6.193x plus 0.807x plus 5 equal to 0. You realize that if you add these two things, you get 7. Okay? And if you multiply them, you will get 5. So let's see what will happen. What is common in these two is x. You factor out x here, so that you have x plus 6.193. Of course, you know that if in factorization, you have a common factor in this bracket. So this should be definitely be x plus 6.193. So if we use this x to divide this 0.807x, you have 0.807 equal to 0. So we have been able to factor that. You see that the bracket is the same. So what we have outside is x plus 0.807 and x plus 6.193 equals 0. Therefore, x plus 0.807 is equal to 0, or x plus 6.193 is also equal to 0. It therefore means that x is equal to minus 0.807, or x is equal to minus 6.193. You can see how I used factorization to get the roots of a quadratic equation that are not factorizable. See you next time.